Imagine a state of matter that's hotter than fire, more energetic than lightning, and yet can be incredibly gentle. This is plasma, the fourth state of matter.
As you heat something up, it starts to change states of matter. So if you have an ice cube, you melt it, turns into a liquid. That means that the atoms got a little bit looser, there's fewer connections between them. Then you boil it, turns into steam, and now it floats in the air, the atoms are even less connected. Heat it up even more, and that steam will turn into a plasma, which means that all of the separate atoms lost their electrons. The electrons are now free, and so now you have this electrified gas.
Plasma, often called the fourth state of matter, is a highly ionized gas composed of charged particles, ions, and electrons. Unlike solids, liquids, and gases, plasma doesn't have a defined shape or volume. Instead, it's an electrically conductive soup of particles often formed at extremely high temperatures. When atoms gain or lose electrons, they become ionized. Plasma requires immense energy to exist. Take the sun, for instance, a giant ball of plasma with a core temperature reaching millions of degrees Celsius, but not all plasma is this extreme. There are various types of plasma. Thermal plasma, used in industrial processes, is extremely hot and highly ionized. High temperature. Thermal plasmas typically have temperatures in the range of 10,000 to 100,000 Kelvin. Equilibrium. The electron temperature and the temperature of ions and neutrals are similar, leading to a quasi-equilibrium state. Fully ionized. Due to the high temperatures, the plasma is usually close to fully ionized. High density. Thermal plasmas have a relatively high particle density compared to non-thermal plasma. Some examples of it are arc plasma, created in electric arcs, commonly used in welding and high-intensity lighting. Inductively coupled plasma, used in spectroscopy for the analysis of materials. Plasma torches, employed in cutting and thermal spraying processes. Cold plasma. Cold plasma operates at lower temperatures, suitable for medical applications and surface modifications. Low temperature. The overall temperature of the plasma is relatively low, often close to room temperature, even though the electron temperature can be high thousands of Kelvin. Non-equilibrium. There is a significant temperature difference between electrons hot and ions, neutrals cold. Partially ionized. Cold plasmas are often partially ionized, with only a small fraction of the gas molecules ionized. Low density. They typically have a lower particle density compared to thermal plasmas. Some examples of it are glow-discharged plasma, used in fluorescent lamps and plasma TVS. Corona-discharged plasma, employed in ozone generators and electrostatic precipitators. Dielectric barrier discharge (DBD), applied in surface treatment and sterilization. Cold atmospheric plasma cap, used in medical applications for wound healing and cancer treatment. And plasma jets, often used in surface modification and biomedical applications. Plasma's versatility shines in its wide range of applications. In industry, plasma is essential for semiconductor manufacturing, precise metal processing, and even waste treatment. In energy production, researchers are exploring plasma-based fusion reactors as a potential source of clean, abundant energy, while plasma torches can convert waste into energy. In medicine, plasma sterilizes equipment, promotes wound healing, and is being researched for cancer treatment. And in space exploration, plasma propulsion systems and diagnostics are pushing the boundaries of what we can achieve beyond our planet. If you found this exploration of plasma fascinating, there's so much more to discover. Dive deeper into plasma research, stay informed about the latest developments, and support efforts to develop innovative plasma-based solutions. Together, we can harness the power of plasma for a better future. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more content on cutting-edge science and technology.